People waste hours reading long forum threads just to find one or two useful answers. Important context gets buried, newcomers feel lost, and teams miss critical insights. TLDR, Smart Highlights fixes that by streaming a concise summary in real time, extracting the most relevant sentences, and linking every insight back to the exact source so users can verify it instantly. The real-world impact is faster understanding, higher trust, and dramatically reduced reading time across communities, support forums, and knowledge-heavy discussions. Now let me show you the application itself. The front end is a Next.js app where a forum thread is displayed on the left and a live summary panel appears on the right. As soon as the page loads, the summary starts streaming in. Users don't wait for a full response. Tokens arrive progressively, forming a readable draft while the model is still working. Once streaming completes, the UI switches to a final digest with 3 to 5 clean bullets. Below that, users see ranked highlights. When you click a highlight, the app scrolls directly to the exact sentence inside the original post and briefly highlights it, so you can immediately verify where the information came from. This experience is driven by a custom hook that consumes a streaming response from the backend using server-sent events. The UI is optimized for perceived speed, skeleton loaders, animated token flow, keyboard shortcuts, and persona switching between novice, technical, and executive summaries. Everything is designed to make long threads feel instantly approachable. Behind the scenes, the streaming proxy handles all real-time behavior. When the front end sends a request, the proxy fetches the thread data from foru.ms, sends it to an LLM using a streaming API, and forwards tokens to the browser as they arrive. It manages backpressure, partial chunks, and clean shutdowns so the stream stays stable. After the stream finishes, the proxy runs a second, non-streaming consolidation pass to produce the final digest, which is more accurate and less prone to hallucinations. That consolidated summary is then sent to the highlights service. During ingestion, every post is split into sentences, embedded, and stored in Postgres with PG vector, along with metadata like thread ID, post ID, and sentence index. When highlights are requested, the service computes similarity between the summary and stored sentence embeddings and returns the top-ranked sentences with confidence scores. This is how provenance works. Every highlight is a pointer back to a specific sentence, not a guess. The system is modular by design. You can run it with OpenAI, Anthropic, or a local mock LLM. There's a FAISS-based fallback for offline demos, and Docker support for a one-click setup that judges can run without API keys. At this point in the demo, we move into the roadmap. Short term, the focus is polish and robustness, hardening the streaming proxy, tuning PG vector indexes, adding edge-compatible vector access, and tightening multi-tenant row-level security. In parallel, we run controlled user tests to measure reading time reduction and highlight usefulness. Medium term, we scale ingestion, optimize embedding costs, and run pilots with real communities. Longer term, we add privacy mode with fully local inference, multilingual support, and embeddable widgets for platforms like Docs or Shopify. From a technical architecture perspective, the system forms a clean pipeline. Forum data flows into an ingestion service that splits and embeds sentences. Vectors are stored in Postgres with PG vector or FAISS. The streaming proxy orchestrates LLM calls and forwards live tokens to the client. The front end renders summaries, digests, and provenance-linked highlights. Offline, a training and experimentation stack fine-tunes summarization and embedding models and evaluates them with reproducible metrics. The final part of the project lives in the GitHub README. It documents how to run the demo locally, how to start the streaming proxy and highlights API, and how to ingest a sample thread. It includes database migrations, vector index definitions, and row-level security policies. The ML section explains the training setup, datasets, and evaluation protocol, including experiments with perforated AI for dendritic optimization. There are Docker files, sweep configs for weights and biases, and clear instructions so reviewers can reproduce results. In short, TLDR, Smart Highlights isn't just a demo feature. It's a production-ready intelligence layer that turns messy conversations into fast, trustworthy knowledge, and the repo shows exactly how to build, evaluate, and scale it. Now, looking ahead, the roadmap. In the next 12 months we prioritize rigorous perforated AI experiments, ingest and curate larger foru.ms exports, and harden the vector stack with PG vector tuning and a proposed Pinecone pilot for sub-100 ms retrieval. At a technical architecture level the system reads like a clean pipeline. Foru.ms provides threads and webhooks to the ingestion service. Ingestion splits sentences, computes embeddings, writes post_sentences in Postgres with PG vector. The streaming proxy manages LLM streams and SSE to the browser. Highlights are computed by querying PG vector via the vector proxy to respect RLS. The front end consumes tokens and displays digests and provenance. Training and experiments run offline with train.py, wrappers for py, and W and B sweeps for reproducibility. The README opens with a project summary and motivation, then provides a fast local quick start that walks you through cloning, creating in .env, running migrations, and starting front-end and back-end. There are clear instructions for seeding a demo thread and launching the Docker demo. The README documents the architecture with mermaid diagrams, an ingestion example, and full Postgres schema including post_sentences and the PG vector index creation statement. It also describes the streaming proxy behavior in detail, including back pressure handling and the SSE event shapes used by the client.